All right, we talked about proportions. We've talked about unit rate. We've talked about how to identify them on a graph. Remember that a ratio is when we compare two different things. We use division to do that. A proportion is when we have two equal ratios. So when we have two comparisons that when we break it down to a unit rate, say the same thing. And now what we're going to do is we're going to take proportional relationships and we're going to write equations from them, okay? And it sounds kind of scary, but bear with me. If you've been paying attention as we've been going, if you've been working with these and have a pretty good idea of how to do it, I think this will click with you pretty quick. All right, so here's where we're going to start. When we have when we're talking about independent variables and dependent variables, right? We have X, we have Y. We have the thing that we're changing, we have the thing that we're measuring, okay? We use those to find a unit rate, okay? And then really what we're saying here is we're saying the dependent variable, right? The thing that we're measuring, it depends on what I start with and what I'm doing to it, okay? So if I'm making, if I know, let's say the unit rate I'm making $10 an hour for my job, my independent variable here would be hours, okay? And then if I change the number of hours, then I can multiply it by the number of, the dollars per each hour, and then I get my dependent variable, which is the amount of money that I have, okay? So dependent variable, this is the same as Y, okay? The unit rate, we're just going to call it R for right now, okay? And then the dependent variable is X, okay? So what we're doing here is we're taking Y, and what it is whatever X is, and we multiply it by R, okay? So when we find our equations, if we know the unit rate, all we have to do is identify what the independent variable is and then what the dependent variable is, and then we can find anything that we want from it. All right, so let's use some situations that we've already talked about, okay? We talked about, we did this from the previous video, right? We have hours worked and money earned, okay? And what I'm looking for here is what's X, okay? So X on the bottom here is hours worked, right? So we're going to take this, and we know that X is hours worked, and we know that money earned is Y, right? So here's hours money earned. Let's rotate it so we have it a little bit better, okay? And we can go ahead and we can identify these things, right? So we can identify these as X and Y. So we know that the hours worked is X, okay? The money earned is Y. And now what we can do is we can say, all right, we know that, all right, the dependent variable depends on the rate at which we change, and then we multiply it by X, or the hours worked, okay? So Y equals RX. Well, in this case, what is the rate at which it changed? So that's why I taught you, if you look at a graph, you look to 1, and we know that it's changing at $8 per hour. So I know that Y is going to be equal to 8 times X. All right, and let's check it. If I take 2, right, these are the X values. So 2 times X, right, 2 times X, 2 hours at $8 an hour. So 2 times 8 is going to be 16. If I come up here and I check, it does equal $16, and it's going to keep working, right? 8 times 3 hours, gives me 24. Y would be equal to 24, okay? And this is just piecing it all together. And if you're looking at it saying, wait, that looks kind of easy, great. Okay, and we're going to do a bunch of examples here, so hopefully you get an idea. All right, next, let's try it again. Okay, we've got hours worked and I've got money earned. What I want you to do here is quickly identify what's X and then what's Y. Okay, remember X is the independent variable and Y is the dependent variable. Okay, go. All right, so hopefully when you did this, you looked at this and you said, okay, hours worked is X and money earned is Y, and my rate, right, my rate is going to be money earned per hours worked, so dollars per hour. So go ahead and you try to find what the unit rate is right now. Okay, so hopefully you've identified Y and you've identified X, okay, and so then let's go ahead and we're going to try to solve or plug in the equation. So hopefully you found that the unit rate is 1 right here. I know it's not written there, but it's 1.12, so $12 per hour. So I'm going to get Y is equal to 12 times X. That's it. Let's try another one. Okay, so First thing I'd like you to do is I'd like you to identify what X and what Y are. Okay. Hopefully you figured out that X is the hours walked, Y is the miles walked. Okay, and in this case it should be pretty easy because I've set it up for a graph, right? These are the X values, these are the Y values, right? Going up and down. So I know that it's X and Y, and so then what I'm going to do again is Y is equal to the rate times X. Well, what is my unit rate here? All right, so hopefully you went 1 hour, 2 miles, so it's 2 miles per hour. So my equation here is going to be Y equals 2 times X. Okay. All right, let's keep going. Next, I've got hours worked and money earned. So let's go ahead and do that first one, the one on the left there. Let's go ahead and first what we need to look at is this a proportion? Okay. All the previous ones were easy to tell that they were proportions, right? The first one here, proportion. It's a straight line. It goes through 0. Proportion. It's a straight line. It goes through 0. Proportion. It's a straight line. It goes through 0. Now this one I don't. So what you could do is you could put it on a graph, okay? Set up a graph and we could plot it out and you could draw a line, see if it goes through 0. You could see if it's a straight line. If it is, great. It's a proportion. That means we can write an equation for it. The other way we could look at it is let's just try to find the unit rate, okay? So try to find the unit rate here for money earned and hours worked. Okay, so in this case, what we need to do is we need to check on each of these, okay, if the unit rate is the same. So let's see, 40 divided by 10 is going to be $4 per hour, right? $4 per hour. But 80 divided by 12, again, $4 per hour. What about 120 divided by 30? Okay, that's going to be 120. That's also $4 per hour. What about 160 divided by 40? Again, yes, $4 per hour. And then last, we have 210 divided by 50. So let's see, 210 divided by 50. Wait a second. That's not $4 an hour. In fact, that's going to be something else. Not $4 an hour. I don't even have to go any further. Okay? I don't even actually have to figure out what it is. I know that it's not $4 an hour, so I know that this is not a proportion. Not a proportion. Okay? Next, let's try the next one, hours walking. First, to decide, is it a proportion? Okay, so let's go ahead. I've got 3 hours walking and 9 miles traveled. So I'm going to say that this is, I'm going to figure out miles per hour. So 9 divided by 3, that gives me 3 miles per hour. And then I do 10 divided by 4, and that's not 3 miles per hour. Not the same. This is also not a proportion. Okay, we can't write an equation from it. Not yet. Okay, let's keep moving on. All right, let's try to find this one. Let's see, from this one, is it a proportion? Let's start there. Okay, go ahead, you decide, is this a proportion? Yes or no? All right, let's check it. So I've got boxes of cupcakes. I've got total number of cupcakes. So let's see, do I want to know number of boxes per cupcake? Well, that doesn't make sense, right? I'm not going to take one box and then see, or I'm not going to do, let's see, number of boxes per cupcakes. What I want to do really is I want to know the number of cupcakes that fit in one box, not the number of boxes I need for one cupcake. Okay, so let's take the total number of cupcakes divided by the number of boxes and see how many fit in each one. So 32 divided by 4, that's going to give us 8 cupcakes. I'm going to call that, let's see, we'll call it just, I don't know, we'll call it cups per one box. Okay. And then we've got 48 divided by 6. That's also 8 cupcakes for one box. And then 56 divided by 7. That's also going to get us 8 cupcakes per one box. And then what about that last one? 80 divided by 10. Yep. So it's 8 cupcakes for one box. All right, now we know our unit rate, right? It's the same each time. Now let's just make sure that it goes actually to 0. So if I back this up to 0, am I going to get, like if I have 0 cupcakes, will I get 0 boxes? And it does, right? Because this is 8 times 4 exactly. If I go back, if I do 3, I would figure 3 would be 24, and 2 would be 16, and 1 would be 8, and 0 would be 0. Okay, so then we're going to get y is equal to r times x. So let's figure out what is x in this case. Well, we figured out that x was the number of cupcakes, right? This is what we changed. And then the number of boxes was the thing that we measured. No, let's see. Oh no, I guess we did change the number of boxes. We changed the number of boxes. We see how many go inside of each one. So we change this and see how many fit. Okay, which I should have noticed here, right? See, it says cupcakes per box. Okay, so the way you do this is, if you remember from the worksheet previously, it's y over x. Okay, r is equal to y over x. So the number of boxes, one box, that's going to be the x values. Okay, so what's my equation? Y equals 8 times x. Okay, change the number of boxes, see how many fit inside of there. Okay, so let's do a little practice here for you guys. All right, number 1, the graph shows the number of muffins that can be made using various amounts of flour. Which equation shows the relationship between the number of flours, F, and the number of muffins, M? Okay, so go ahead, figure out which one of these it is. Okay, hopefully you looked at this and you said, okay, these are the x values, right? And then these are the y values. So it's going to be, if you do y equals r times x, y is the same as m, right? That's up here. M was muffins. So the muffins is going to be equal to the rate, right? The number of the number of muffins I get for each cup of flour, right? So F. So then what is my rate? Well, if I look here, okay, 1 cup of flour gives me 6 muffins, so muffins will be equal to 6 times F. Okay. Okay, go ahead and do this one. All right, so we're looking at this one. This one says, what is the meaning of this, right? So if you look at this, this is my unit rate. Here's one box. Gives me how much? Okay, well, if I know if 2 lines is 1, then how much is this? Well, that would be 1/2 of a pound, right? So 1 box weighs 1/2 a pound. So 1 box weighs 1/2 a pound. Okay, try this one. All right, so what I might do here is I would say, let's see, which equation shows the relationship between the number of cards and the total cost, okay? Well, they already set this up for us, right? We know that y equals r times x, right? They already said y is c, okay? And n is x, the way they did this, okay? Times n. All right, so then what I'm going to do is I'm going to set up a little table, n and c, okay? So again, this would be x, this would be y. And you could graph it if you want, but what I'm going to do is I'm going to say, okay, 2 cards is $5, right? So 2 cards, $5. 3 cards is $7.50. And 5 cards is $12.50. And 8 cards is $20. Okay, cost in dollars. This is cards. Okay. So first, if I plug in 0, 0, does this thing look like it works pretty well? And I would say yes, because let's see, if it's 5 for 2, okay, if I back it, let's see, so 5 for every 2, if I go to 8 here, right, so 20, well, let's just find the unit rate, okay? So what we really want to do is let's go back and let's see if 1 works. So we'll do, how much does 1 card cost? Okay, so if I divide all these, what you're going to find is 5 divided by 2 is 250, this 250, this 250, 8 divided by, or 20 divided by 8, all 250. So every one of these, right, is going to end up being $2.50. Okay, and if I back this up to 0, right, if I drop back to 0 and I go down 250, I'm at 0, 0, right? So there you go. Each card is $2.50. Try this one. Okay, so in this case, we know that r, right? So it's y equals r times x. Okay, so y is, in this case, r, which is going to be equal to the number 3/4. Okay, and then whatever b is this, right? So we know that, let's see, r is raisins. So the number of raisins I get, okay, is equal to 3/4 of the batch of trail mix. Okay, now if you remember, my rate from the earlier is you do y over x, right? So because what we're doing is we're doing the number of raisins, okay, raisins for one batch, okay, right? Raisins per batch. Now it's y values, the y things, raisins for each batch. Okay, so then if I change this, if I make this, what they're saying here is it's the same ratio. It's 3 raisins for 4 batches. Okay, now remember, x is b and y is r. So if I'm going to plot this as a point, okay, normally I do x comma y. All right, when you graph a point, like if I were going to graph a point somewhere, I'd go left and right, and then I go up and down. So x comma y. But what is x in this? It's the number of batches, comma, the number of raisins. So my correct answer is, right, it's how many batches? 4 batches for 3 raisins. And if I look over here, my correct answer is B. Okay. Last one. Okay, so let's go through this. Which statement is not correct? Okay, the data represents a proportional relationship. Is that true? It goes through the origin, straight line. This one's good. The point 5, 2 means that Nipper eats 5 pounds of dog in 2 days, or 5 pounds of dog, 5 pounds of dog food in 2 days. 2 days, right? Or let's see, 5, 2. So I got to go 5, 2. So 5 days, 2 pounds, right? 5 days, 5 days, 2 pounds, right? Look, 5, 2, 5 is days, right? So 5 days, 2 pounds. Okay, so we look at that. So 5 days, 2 pounds. So this one is not, this is the flipped, right? So this is not true. But let's keep going, right? The point 0, has no meaning in this situation. Well, that's not true. It means in 0 days, excuse me, the dog has eaten 0 pounds of food, right? And in this case, the constant of proportionality is 0.4, meaning the unit rate is 0.4. Well, if I look here, if I do 5 and 2, right? What I'd do is I'd say 2 pounds in 5 days. Okay, and if you divide this, I'm going to do 5 into 2. Well, does 5 go into 2? No, so I got to break it into tenths. 5 goes into 20, 0.4 times. So my constant of proportionality, or my unit rate, is actually 0.4. We knew that this one is correct. So B is the one that is not correct. So this would be the correct answer. Okay, or that's the answer for this question. All right, hopefully you have a working idea of how to do some equations here. We will practice more in class tomorrow.